discussed about the different models of single board computer system. Okay, including Raspberry Pi, Beagle board, and NVIDIA, Dragon board, etc. So different boards we have seen, and I have given you one assignment. Okay, so have you worked on that? Once again, I will show you. Top single board computers. You have to submit assignment on top single board computers for 2020. Okay, so I have provided you with the link, and on this link you can go and see top 10 single board computers for 2020, and you have to write down basic features of these all single board computers handwritten, and you can paste images. Okay, you can form a Word document. In that Word document, you have to paste image of that board plus image of whatever you have written, and make a table of 10 top SBC. Okay, so and that you can submit for internal assessment, your internal assessment. Okay, so this is what we discussed yesterday. So today we are going to discuss about the network access devices which are used in the single computer board systems. Okay, so as we have discussed earlier, we have seen that networking has become very important part in our day-to-day life. It may be wired or it may be wireless. Okay, so if you take example of Raspberry Pi single board computer system, then it has onboard network adapter. Okay, and it has Bluetooth as well as wireless LAN connectivity. It has standard communication ports such as CAN port, that is controller area network port, UART port, USB OTG port, I2C port, and 10 or 100 megabit Ethernet. So all, I think we have discussed these things yesterday. Okay, so UART means universal or synchronous receiver transmitter. USB OTG means USB, all of you know, universal serial bus. OTG means on the go. I2C, basically it is used for sound, so inter IC sound system that is used, and 10 Mbps and 100 Mbps Ethernet, that is wired network facility, or this port is also available on your board. Okay, so these networking facilities, they are generally available here. Okay, so for wired Ethernet cables, generally RJ45 connectors are used. This we have already studied during first semester, RJ45 connector. You might have seen this RJ45 connector in your telephone connection. So, or in your internet connection in your laboratory, you must have seen RJ45 connector. Okay, even Ethernet patch cable can be used for that. And if you consider Raspberry Pi, then operating system used for Raspberry Pi is Raspbian. And in this Raspbian operating system, there is a provision to connect to any network using what is called as DHCP, that means Dynamic Host Configuration Protocol. By using this Dynamic Host Configuration Protocol, you can connect your single board computer to any network. Okay, so this DHCP protocol is going to automatically assign IP address. Okay, so automatic configuration is there. There are a number of methods for setting up of Wi-Fi connections with single board computer system. Generally, the operating system which are used for single board computer system, they have network icon, and you can see this network icon on the screen. So you have to select this icon. The user is presented with the list of Wi-Fi networks available, and with appropriate sharing of the password, user can be connected to the said network. So there is very simple way to add such type of or to form such type of networks. And many times what is done, this is very important. What is done is many single board computer systems may be linked together to form what is called as a cluster. Okay, and this cluster can be used to replicate the data center. Okay, so this is a very important concept which is used in single board computer system, and this is a data center which is very low priced. So this is what is importance of the cluster which is formed with the single board computer system. Okay, and even there is use of wireless sensor network for various purposes, and this wireless sensor network is basically benefited by the use of single board computer system due to their low power consumption. Okay, so use of wireless sensor network is uh, powered by the single board computer system. Okay, now on the screen what you can see is the list of the network access devices on single board computer system. Wired or wireless network connectivity is provided on board, network adapter on board, wireless connectivity to Bluetooth, wireless LAN, and even to 3G network is provided here. Wired industry standards such as CAN, UART, USB, OTG, I2C, and Ethernet, they are used. And the last concept just now I have discussed is forming a uh, cluster, forming a cluster of a single board computers together to replicate the data center. So you have to remember these important things about your network access device. So here you can observe even the Ethernet port that supports gigabit connection is also available. Along with 10 and 100 Mbps nowadays, giga bit Ethernet connections are also available, and Bluetooth version 4.2 and Bluetooth low energy version is also available. Yeah, basically which is suitable for wireless sensor network. Okay, radio support for 802.1. The standard which is used for Wi-Fi is 80.11. Okay, so this is running on 2.4 gigahertz, which is ISM band, which is free band, industry, scientific, and medicine. So for this purpose, this 2.4 gigahertz frequency is available freely. So even 5 gigahertz frequency band is available. So actually this is licensed, and 2.4 is not licensed. Okay. So Topaz networking switch, it may be available on the single board computer system. Okay. So all these things are available. Virtual network connection is also available. So all these network access devices, you must remember about your single board computer systems. Okay, so here we are ending the chapter number 1 of your paper number 1. So study with reference to your multiple choice questions. Okay, so give stress on that also. I think textbooks of Vision publication has been published. So for both the papers, you can buy them from the market or any other textbook if you want. I'm providing you with the these PowerPoint presentations, and these PowerPoint presentation, they are just like notes. So those are sufficient as far as your notes are concern. Okay, so I'll be also giving you some sample multiple choice questions, just like previous. Okay, so today we have completed chapter number 1 of paper number 1, and today we are going to start with again paper number 2, chapter number 2. So first we will complete paper number 2, chapter number 2, and then we will go to paper number 1, chapter number 2, which is system on chip. Okay, so let us start with the chapter number 2. हॅलो मुलांनो, प्रेझेंटेशन दिसतंय का नवीन तुम्हाला? म्यूट केलं होतं वाटतं.
हो मॅम.
हा,
हो दिसतंय.
दिसतंय ना? ओके. So we have to start with the chapter number 2 of paper number 2. Chapter number 2 of paper number 2 is short range wireless technologies and location tracking. So two things we are going to study in this chapter: short range technologies like Bluetooth, Zigbee, and RFID, Z-Wave, even Z-Wave. So Bluetooth, Zigbee, Z-Wave, and RFID. So these four technologies we are going to study in short range technologies, and location tracking technology, which is GPS. So that also we are going to study in this particular chapter. Okay. So let us start with this. So today we'll be starting with Bluetooth. As all of you are using Bluetooth, you know that this is a short range communication technology, and which was intended to replace the cable connections, okay, for portable unit. So enabling the wireless communication for shorter range and replacing the wire technology. This was the objective of the Bluetooth technology. Okay, and this Bluetooth technology is based on what is called as ad hoc networking technology. Ad hoc networking means this network is not like your infrastructure network, but it is on the fly or on the go type of network, in which there is no some fixed infrastructure, and there is no any master here, but still master is there, but not like that of base station. Okay, and all the terminals, they are connected in peer-to-peer mode. Okay, they are connected in what is called as peer-to-peer mode. So this type of connection or this type of network is called as a ad hoc network. So generally Bluetooth technology is used to form ad hoc network. Now if we consider the frequency range of this Bluetooth network, it uses radio frequency for communication, and it uses the ISM band. Just I have mentioned you what the ISM band is. ISM band is license free band. It is called as industry, scientific and medical use frequency band. So this is a free band which is available, and this frequency is used by your Bluetooth technology. Now, this Bluetooth technology comes with some of its unique features, and these features are it offers uniform structure for wide range of devices. Okay, so uniform structure is a very important thing, and due to this uniform structure, it has got a global acceptance. Okay, so due to global acceptance, it is widely used. The third advantage or feature of this Bluetooth device is that it's low power consumption. Okay, and offers up to a quite good range of communication up to 10 meters. Okay, it can be used for interactive conferences through the ad hoc networking of laptops. Okay, you can form an ad hoc network of laptops using Bluetooth. And it can be used for various devices like cordless computer, that is your laptops and mobile phones, cordless phones, intercoms, all these can be connected by using Bluetooth. Okay, so now let us go to the basic architecture of this Bluetooth. So basic architecture of the Bluetooth can be divided into piconet and scatternet. Okay, so small network of Bluetooth enabled devices is formed, and this network is called as piconet. Okay, pico means it is very small. So piconet is formed, and this piconet is basic building block of your scatternet. So you can form big networks by connecting small piconets together in a ad hoc configuration. Okay, so such a large network formed out of these piconets is called as scatternet. So basically, the Bluetooth architecture consists of piconets and scatternet. You have to remember this. So in piconet, you can connect total 8 devices. Out of these 8 devices, one is master. The device which initiates the communication becomes master, and remaining the devices are called as slave. So for one master there can be maximum up to 7 slaves. Okay, so slave to slave communication is not there, master to slave communication is there. Master can communicate with the slave, slave can communicate with the master, slave can communicate with the slave through the master. Okay, so this is the way in which the piconets and scatternets are used for communication. Okay, so these are simple things. You will remember this. So here you can see the diagram of scatternet as well as piconet. Okay, so basically master is responsible for control. Okay, transmission control, and time division multiplexing is used here for communication. So forming time slots and all this management is carried out by the device which is called as a master. The slave in one piconet can be master in another piconet. Okay, so slave in one piconet can be master of another piconet, but one device cannot be master of 2 piconets. You remember this thing. Okay, this is very important. Now, Piconet, within the Piconet, the timing of various devices, and as it is using frequency hop type frequency spread spectrum technique for communication. So frequency hopping sequence and timing slot interval, and its 48 bit unique address of the master. All these things are handled by the master only. Okay. So as I told you, these devices can communicate simultaneously, and several piconets can communicate with each other simultaneously. Okay, so these networks are established automatically and dynamically. So this is very important feature. They are established dynamically and they are established automatically. Okay, so uh, as I told you, there is no direct connection between slaves. All connections are essentially through master. Okay. Um, the extensible infrastructure is can be obtained by repeating these or connecting together these piconets to form the scatternet. So this is the basic architecture that you have to remember. Okay. Now, here what you can observe is that slaves are allowed to transmit once, okay, and these have been polled by the master. So once the slaves are transmitting, each slave is polled by master. So master is going to see whether this slave has data, this slave has data. So if it has data, then it will accept it and it will send back some data to it. Okay. So so this transmission starts in slave to master time slot immediately. Okay. So communication is occurring in the form of packets, as this is digital communication. Communication is offering in the form of packets. Okay, so many things already I have explained to you earlier. Okay, here one important thing you can observe here is that device residing in adjacent piconets provide a bridge to support inner piconet connections. Okay, piconets are linked together to form these or to extend these networks physically. Okay. Now, some of the specifications of a Bluetooth network here are given. The spectrum, as I told you, it is using ISM band, and you remember this frequency range. Frequency range is from 2.4 to 2.485 gigahertz. Only these in these frequency range the Bluetooth is operating. Okay, so it is using spread spectrum technique, frequency hopped spread spectrum technique, with hopping rate of 1600 hops per second. That means it is changing frequencies 1600 times per second. Okay, so these things you have to remember about the spectrum of the Bluetooth. It is important. Now, let us go to range that can be provided by Bluetooth, and there are three classes of Bluetooth devices, and they are class 1, class 2, and class 3. Okay, so class 3 Bluetooth devices have range up to 1 meter. Class 2 has a range up to 10 meters, and class 1 they have range up to 100 meters. So at max you can have 100 meters of the range. Okay, and if you see the data rate supported by Bluetooth version 1.2 is 1 Mbps, and that by 2 is 3 Mbps. And you even recent data rates you can find out from the internet, and there is need to do so. So you find those all things because it is important from the point of examination. Now let us go to learn about the Bluetooth protocol architecture. So just like your SI model, it has a layered architecture, as you can see here. Basically, it is divided into 4 layers. And these 4 layers are, as you can observe here, physical layer, data link layer, middleware layer, and application layer. So these are the 4 layers which are present in Bluetooth architecture, protocol architecture, as you can see. Okay, now let us start the discussion with each layer. So first layer is your physical layer. Okay, so as the physical layer consists of 2 sublayers, as you can see, and these 2 sublayers are radio and baseband layer. Radio layer is there and baseband layer is there. So radio layer basically it deals with the connection. This is wireless connection, as you know, and wireless connections are of 2 types. One is called as connectionless link, and another is called as connection oriented link. So 2 types of links are present in Bluetooth: connectionless and connection oriented. Connection oriented means before data communication, the connection between the 2 devices has to be established, and then only there can be data communication. But in case of connectionless, directly you can start with the data communication. So this is the basic difference between connectionless and connection oriented links. But both kind of links are available in the radio of the Bluetooth. Okay, so this physical layer lays down physical structure and physical specification for the transmission of radio waves. So it is going to define the air interface, frequency bands. Just I have told you which type of frequency band is used, and frequency hopping specifications are also there. So 1600 hops per second, and modulation techniques used here generally GFSK type, Gaussian type frequency shift keying modulation technique is used here for Bluetooth radio. Okay, so these things are concerned with the radio layer, sub-layer of the physical layer of Bluetooth. Okay, there is another sub-layer which is called as baseband layer. So this baseband layer particularly is responsible for performing the connection or establishment within a piconet. Okay, so it takes the services of radio protocol. So it uses the radio protocol, and by using this radio protocol, it establishes the connection. Okay, so to establish the connection, it will define the addressing scheme, the packet frame format, various timings, and power control. Okay, so different types of algorithms and formats, they are present in the baseband of the physical layer. So in this, we are going to study the frame format of Bluetooth. Okay, so that also we are going to study ahead. So as you can see, the basic layer is made up of radio layer and sublayer and baseband sublayer. Radio layer is responsible for air interface, and air interface will include the frequency band and hopping specifications and modulation scheme. And baseband is particularly for establishing the connection, and as it is taking part in establishing connection, it will define addressing scheme, packet frame, timing, and power control. Okay, so remember these uses or functions of each layer and sublayer. Okay, now the next layer that we are coming across in Bluetooth is data link layer. So here you can again observe that it includes 2 sublayers. One is called as LMP and another is called as L2 cap. So these 2 sublayers are there in data link layer. Okay. So the first layer, sublayer of this data link layer is LMP. LMP means link manager protocol. So this is a protocol. It is a set of rules. Okay. So it is going to establish the logical links, not physical links. Okay. Physical links are established in the physical layer. And in data link layer, the logical links are established between the Bluetooth devices. Okay. So this links are enabled for the communication. So apart from this, so the first function is already uh, links, physical links have been established, but a logical link has to be established, and all management of this link is done through this logical link protocol. Okay, so management of links is carried out with help of the link manager protocol. As its name is manager, it is going to manage the links. Okay. Apart from managing the link, it will also perform authentication and encryption processes. Okay. So authentication of the device, whether the device is authenticated or not. And if you are transmitting and receiving data, so this data must be secured, and that must be encrypted and decrypted. So this encryption decryption process, overall it is called as encryption process. This is carried out by the link manager protocol. Okay. The second sub-layer of the data link layer is logical link control and adaptation protocol. Logical link. So these are two L's: logical link control and adaptation protocol. Its short form is L2CAP. So this L2CAP basically is a heart of Bluetooth protocol stack. So this is very important layer which is present in the Bluetooth, and basically it allows the communication between upper and lower levels of the Bluetooth protocol stack. So it acts as interface between upper layers and lower layers of the Bluetooth protocol stack. So how it is going to establish communication between these upper layers and lower levels? What it does is it receives the packets from upper layer. So the received packets are not in the form which are so suitable for lower levels. So this layer is responsible for making the data packet suitable for lower layer. Okay, so this is called as segmentation, and these packets are delivered to the lower levels by using a multiplexing scheme. So both segmentation and multiplexing processes are carried out in the L2 cap layer. Okay, so L2 cap layer, as Bluetooth supports CO as well as connection oriented or connection-less services. Okay, so connection-less services basically asynchronous service, and connection-oriented service is a synchronous service. So this L2 cap will support both, and hence Bluetooth is supporting both type of links, connection-less as well as connection-oriented. Okay, now let us move to the middleware layer. So this middleware layer, it consists of again number of sub layers or protocols, you can say. Okay, this may include radio frequency communication protocol, which is RFCOM. It is also called as RFCOM. Okay, so this RFCOM is present here. This protocol is present here, and adopted protocols are there. So some standard protocols are there. These standard protocols are used and adopted for the Bluetooth, and such kind of protocols are called as adapted protocols. And there is service discovery protocol. So this is again set of rules which is used to discover the services. And AT commands. So generally AT commands are used in telephone communication system, your landline communication system. These AT commands are also present in the middleware. So with help of all this, the Bluetooth is operating. Okay, so let us go to first part of this, which is RFCOM, which is a radio frequency communication protocol, or it is also called as radio front-end component. It is also called as radio front-end component. So it provides the serial wireless communication. It provides the serial wireless communication, and it is using WAP protocol. Okay, wireless access protocol. Sometimes it is also called as wireless application protocol. So you must know this. Okay, there is one more protocol which is used in RFCOM, and that is OBEX. OBEX is a object exchange type of protocol. So here we are communicating digitally, and we are communicating the messages with help of